Thank you, Rachel. Thank you very much. With your, assistant, I really need your help. Okay, I forgot to record. All right. But all these consequences, I think we use the example to to show all these consequences. Okay, and okay, so number 3, the T and F test, based on the standard assumption of classical linear regression model, may not be reliable, resulting in erroneous conclusions regarding the statistical significance. Since T is related to p-value, F is also related to p-value, and this T and F cannot be reliable, then the p-value is not reliable, then the result of hypothesis testing is not reliable, right? Okay. Number 4, in the presence of heteroscedasticity, the blue means from the OL as estimation are provided by the method of weighted least square. Don't worry about this one, okay? All right? I'll show you some examples, and then you will know. Okay? Because of the consequences, it is important that we check for heteroscedasticity, which is usually found in cross-sectional data. And I like to use one of the examples in our textbook from chapter 10, which is called gas, okay, to show the heteroscedasticity. Let's see. Excuse me. Okay. Okay. So let me use the example of gas, number 10. And, since you already download Gradle, I didn't show the Gradle for all of you, right? So in this time, I'm going to show both Gradles and eViews for these examples, okay? And let me show Gradles first, okay? And I haven't shown this Gradle functions to my master's students in business school either. So let me do it. Okay. If you want to run the Gradles, okay, you all have this, then just click it. I'll change it to the English version, okay? Then everybody will know that. Okay, shading. And okay, then everybody know this interface is in English. Okay. If you have the Gradle and you wanted to, I imported it from the Excel. Okay, and usually you need to have the updated Excel versions. Do not use like something 97 to 203 versions. I think it doesn't work here. Okay, you have to update it. It's easy to update it. Just update it to the latest one. Okay, so just draw in. Okay, and let's see the variables first from Excel. What do I have? I have all these observations, which is 50 observation, right? And I'll have all the states from USA. Okay, from Alabama, A to the Wyoming. I think the last one is Wyoming. Okay, and I have variables. This is PCON, price, REG, and POP. Okay, I will explain this definition later on. So actually, what I need for my data is from column 3 to the rest of them, right? Okay, in that case, the Gradle asked me, start import at what? I just use 3 column. I change it to 3. And the first row, okay? Since the first row is the variable name, I need that variable name, okay? So I change this 1 to 3, okay? And I hit OK, okay? If you hit OK, they will ask you that whether it is a time series or panel data. Nowadays, since it is cross-sectional data, so I will say no. In the future, if we go up to the time series topic, then we need to click yes. So today, for these examples, I hit no, okay? Then this is the variable list of the Gradle, okay? All right, and at the same time, I think we can do that for eViews. So eViews, let me do this one. Okay. And this one, and I have eViews, and I have Gradles together. Okay, for Gradles, all the functions is on the top. You see the file, tools, data, view, add something. And look at this model. Okay, model. The first one is ordinary least squares. So I just hit the first one. And YCON. Let's see the definition of them, okay? This is from our data, okay? PCON is the petroleum consumption in the ith state. So PCON is petroleum consumption. And REG is the motor vehicle registrations in the ith state. Okay? Then price is the price of gasoline. Okay, so price is the price of gasoline, and REG is the motor vehicle registration. All right, so I put PCON in the dependent variables, and price and REG as an independent variable. So far, I just put this one here. You use the dependent variable. And did you see this say regresses? Means X variable. Then I hit OK. Then this is the output from Gradles. And it is price REG. Open as an equation and OLS. Okay? Look at the output. Are they exactly the same? But eViews put a constant at the bottom, and Gradle put a constant at the top. And the rest of the p-value, look at this one. For eViews, just show the probability. Let me see. Show the, I think I can, this one can be larger, okay? The probabilities for both of them. And eViews doesn't put the star signs. And eViews, Gradle put the star signs, okay? There's a 1 star sign, 2 star sign, and 3 star sign. The 1, 2, 3 star signs denoted as 10%, alpha equal to 10%, 5%, and 1%. So the more star, 3 star, is the alpha is the lowest one. Okay? And remember, all these p-value are two-sided test. Okay? So what did you see? What did you see from this one? Let's look at the relationship. Petroleum consumption with the price should be negative, right? The price of the gasoline higher, the consumption is lower, negative, right? Okay, the more motor vehicle registration, the higher petroleum consumption, right? So positive. Okay, so looks pretty okay. Okay, then how do I know I have whether I have a heteroscedasticity problem? What brings you to think about whether I have heteroscedasticity problem? You know, we know that 50 states in the United States, there's some big states, some very small states, right? Right? So first of all, maybe we can see some diagrams. Okay? From the diagram, I think the first glance to find out that there's any different X levels will have different variations. We can check with the graph. Okay? So let's see some graph. How do you see the graph? Let's look at the graph of grados. So residuals, I may see against price, see regulation, registrations. Okay? So do we see something from here? The higher, the more the value of the registration is higher, the variation is bigger. So look like these diagrams is like this one, and it turns out to be, you know, just like a trumpet. You know? The trumpet, I mean. Did you see that? Okay. The diagram here shows the heteroscedasticity problem. Okay, this is the, you know, glance from the pictures. But, you know, sometimes from the pictures, we may not really see something from it. Okay, we all like to see some numbers which we can, you know, test for. Okay, and like multicollinearity, you know, we can calculate the VIF, we can calculate the partial correlation coefficient. Okay, here we suggest you to do some tests. Okay, and what are those tests? Okay, you can see from your textbook, the most popular one we're using, okay, so far, is what we call BP test. Okay, this is on our textbook, the page of 334. We call it Bruch-Pagan test. Bruch-Pagan, so it's easier to just say the BP test. Okay, all right, let's get out of the diagram here. Okay. If I wanted to see the test, okay, did you see the grados? There's a function called test. Okay, and did you see this one? Heteroscedasticity. Did you see that? And there's some test showed it. Okay, now we have 4. Actually, it's 2. Okay, one is y-test. A y-test. This is squares only. I'm explaining this test in details later on, and you'll see the difference. And this is Bruch-Pagan. Okay, Then the last one actually is the Bruch-Pagan tool. But since there's somebody else to involve in this test, therefore they're using this DEMS, but actually is the same as BP test. Okay, and let's see the rationale. Okay, the rationale for BP test first. Okay, the rationale for BP test says that, okay, if I, for example, let me or maybe I'll show the word here. Show my, okay, let's see the anything about BP test. Okay, look at this BP test. If we run the regressions, we did run the regressions, right? After we run the regressions, and we like to see the movement of the residual. We just see from the diagram. The vertical line is the residual, but we square it. Okay, square the residuals, and using that as the dependent variable. This square residual means after I run the regressions, what is in the residual after I run the regression? If I have the variables x1 and x2, after I run the regression, what else in the residuals? What's this residual part mean? If I have x1 and x2 variables, I use the y to run this x1, x2. What's the residual means? Means the variation of the y after two variables, x1, x2. They explained the variation. So whatever does not explained by x1 and x2 is in the residual. Understand this one? Okay? So if we can use the residual as a y variable, okay, then used original x1, x2 as an x variable, then what do we want to see? We want to see, is there anything left out in the residual? Also, it still can be explained by original x1 and x2. In that case, means there's something which the original x1, x2 doesn't explain it. Does that make sense? If, for example, if I should have square terms in my original regression model, okay, x1 is already here. It's already in the model, but I don't have square term. This means functional form, the wrong functional form, okay? So whatever the square terms, the information from square terms didn't explain the y variation, all left out in the residuals. Understand what I'm saying here? Okay? Agree with me? So I'm using residuals as in y variables and using original x and x variables, see whether there's a relationship exists among the residuals and the original x variables. That's the concept, the original idea from BP test. Does that make sense? I think that's they started with. Okay? So this is what I'm saying, that use the square residual as the dependent variable in an, here, again, auxiliary regression. Since I'm not using original y as in y, they use the residual terms as in y and run the original x variables, then this is another form of auxiliary regression. Okay, we call this auxiliary regression Then, okay, the first one said if you strong suspect that only certain variables are a plausible factor, then you should run the BP test using only suspect variable. But all the computers, including the original X variables. So they start with this original X variables. If you want to do that, you have to do it by yourself. Okay, so you have to run this residuals as a Y, then those suspect X variables and X, and do it by yourself again. Okay, so I'll come back to here. Okay, look at this. If I use this is what we call BP test. Okay, I hit this one. Okay, look at this one. Dependent variable is what? This U hat square is the residual square. Okay, then the original X variable, price and registrations. Okay, then what we want to know is not the result of the output, is the test statistic. Look at this p-value. Okay, look at this one. This is what. So let me write down here. If I'm running all the residuals squares and Y variable, and this one, more ink, okay? And I'm using alpha 1, and this is X1 variable. I'm using 2 variables as an example, just like our book shows, okay? And after I run it, okay, then this one will be the estimate. So what am I going to do? The hypothesis testing is what? I wanted to see the residuals. Also, there's something which X1 and X2 can explain it. Okay, so I'm testing where alpha 1 and alpha 2 is equal to 0 or not. If it is equal to 0, there's no heteroscedasticity exist. If either one of them, at least one alpha I not equal to 0, I equal to 1 and 2. So I'm testing this one, and this p-value tell us the p-value is pretty close to 0. What does that mean? It's must be less than 0, alpha, right? So reject or do not reject. This one, when p is smaller than alpha, is reject null hypothesis or do not reject? Reject. So reject means what? You reject this one, right? So this one, you support this one. So at least one of this one not equal to 0 means what? Heteroscedasticity exists. So in other words, this means no heteroscedasticity. This means heteroscedasticity exists. So when you reject the null hypothesis, means the regression do have heteroscedasticity problem. Okay? All right? So the idea of the Y test is pretty similar to the BP test. The only difference is BP started with only original X variable. But the Y test extended from the original X variable to the square terms, to the cubic term, etc. Okay, so look at this one. If I'm do this one again, this one, Y test. Did you see that? And did you see this Y? The second one just squares only. But this white, did you see that? They're using two variables, an example. I have the original price and also the registration. I also have the square term for both of. Then I will have what? The combination of X2 and X3 together. So it's a cross product terms. So the white test consider the square terms as well as the cross product terms. But what's the problem if I have include all the different kinds of terms? When you run the regressions, if I have two variables, and for BP test, look at this. Let me show the BP test here. Okay, this is a BP test. Oh, okay. By the way, there's good things is that after I run the test, all the result will automatically, write it on my original output. If you run the Grados, you don't have to, copy that all this information. It's on the output, so you can have all of them as an output together in the Word file. Okay, look at this BP test. Okay, this is a 2 degrees of freedom. This is a chi-square with 2 degrees of freedom. Means what? I have two variables, since just x1 and x2, right? How about Y test? I have the original two variables with their square terms plus the cross product terms, which is 5 degrees of freedom. So there's more degrees of freedom. The difference between these two, there's more degrees of freedom. If you have more degrees of freedom, then you lost some information in statistics. Okay? Although these two results, really shows heteroscedasticity problems. And this is what so you can try this 5. You can try the BP test, BP and white with 4 different versions, okay? And where do I get from the e-views? Where do I get it from e-views? Okay, again, from the output, okay? See the view. And now you see the residual diagnostic. Did you see that? And choose heteroscedasticity test. Did you see that? Hit it. And there's several ways, not only BP, but also Harvey and anything else. And white is there. So choose BP if you want to test the BP. If you choose white as you want to test white. So for example, I'm using BP. And I hit OK. This is the BP test from eViews. And where is my BP? Okay, this is the BP from Grados. Okay, look at this one. it seems that e-views is there's a three ways to do the hypothesis testing, and it seems that the BP using look at the probabilities here. This is so small, right? So maybe this one is matched with this one. You all with me? Huh? Still with me? Only 5 minutes left. You all with me? Okay? So, go back home and play with it. Okay? This is two tests. One is called BP test. The other one is called Y test. And these two tests is the most popular way to test heteroscedasticity. Okay? And we'll see the remedies next time. But next time, remember to turn in the assignments and do the presentation. Okay? Any questions? Do I make myself clear in today's lecture? And do you make yourself clear? These two packages you can use interchangeably. I don't care which programs you do, okay, or any output. Okay, by the way, for the Grados, look at this one. File and save as. Then it will save as a Word file. And hit the OK. And you may name it on the desktop. Maybe this is okay. I just use the variables one. Okay, then I save it. Okay, I'll see what do I have from my desk. I save it on the desk. Look at this one. This is. So I can change it. I think I can change it to this one. Look like this one. Do you see that? Okay, so it is also easy too. Well, or maybe you can just print screen. It's okay. Either way, I don't care what way you do it. Okay. Did you see that? Okay. All right, that's for today. Thank you very much.